On January 7th, 1610, the universe, as we knew it, just shifted.
They really...
An Italian natural philosopher, Galileo Galilei, he points this new telescope he built up at Jupiter. And what he sees are these 3, and then later 4, tiny little points of light circling the planet.
And this wasn't just, a neat discovery.
No, it was an astronomical dagger, plunged right into the heart of 1,500 years of accepted truth about the cosmos.
Everything they thought they knew.
That single observation changed everything. And then you fast forward just 23 years.
And it's a completely different picture.
That same man, the guy we call the father of the scientific revolution, is standing before the Roman Inquisition. He's being threatened, forced to publicly denounce his own work.
To deny the sun-centered universe he...
Welcome to the Deep Dive. Today, our mission is to unpack that entire journey, the whole life of Galileo Galilei. We're looking at his life, his genius as an engineer, his incredible discoveries.
And the conflict, the intense, escalating conflict his work created with the established order.
Exactly. We have a whole stack of sources here that cover the full sweep of his career. I mean, from his financially shaky beginnings all the way to his sort of final defiant act of publishing his masterwork from under house arrest.
It's an incredible story.
So for you, the listener, we're going to try and distill how this one man, just by insisting on observation and reason, fundamentally changed the whole relationship between science and faith.
And what it cost him. You can't forget what that battle cost him personally.
That's the core of it. This isn't just about looking through a piece of glass. It's about a decades-long fight to make the world open its eyes. Okay, so let's unpack this. How did this brilliant man go from a revolutionary stargazer, a celebrity scientist selling telescopes, to a persecuted man locked in his home for the crime of believing the Earth moved?
To really get it, you have to start with his foundations. And specifically, you have to start with the money or the lack of it.
It always comes back to money, doesn't it?
Almost always. He was born Galileo di Vincenzo Bonaiuti de Galilei on February 15th, 1564 in Pisa. And while his family was, educated, middle-class Florentines, the sources really stress that his life defined by this push and pull, intellectual ambition on one side, and just constant financial insecurity.
And his father, Vincenzo Galilei, was a pretty significant figure himself.
Oh, absolutely. A respected lutenist, a composer, a real contributor to Renaissance music. He was accomplished, but he was never solved. The life of a musician back then.
A touring musician.
Exactly. He spent a lot of time traveling around the Italian city-states, a semi-itinerant player, always trying to find reliable patronage at the...
So you have a father who was often gone, chasing work, chasing money. That must have left the family's stability just constantly up in the air.
It did. And it deeply, deeply impacted Galileo's upbringing, his later choices. The family really relied on the security that mother, Mamadi. Her family was more established, more scholarly, business folk.
So she brought the stability.
Her dowry and the money from her father provided this essential, though pretty strained, cushion for the whole family.
It's interesting, too, that the family was ambitious enough to sort of claim this historical pedigree. The name Galileo itself wasn't random.
Not at all, no. It was an inherited name. It linked him back to an ancestor from the early 15th century who was a doctor, a politician in Florence, right when the Medici family was on the rise. So they had the cultural and intellectual chop, but practically, day to day, they were struggling.
And that financial strain, it didn't just stop with his father. It cascaded down to Galileo himself.
It really did. He was the first of 6 surviving kids, and his relationship with his younger brother, Michelangelo, that became another huge source of financial stress.
He also became a lutenist, right? Like his dad.
He did, and one who was frequently in debt. He was constantly leaning on Galileo for money, which basically forced Galileo throughout his career to prioritize jobs that offered a guaranteed income over ones that just offered pure intellectual freedom.
That pressure to earn, it must have shaped his early academic choices. He didn't just jump straight into math or physics.
Oh, no. For a while, he even considered joining the clergy. He spent time at the Benedictine Abbey at Vallombrosa and seriously thought about it. It was a common career path for a son from his class, but his real passion was elsewhere. By 1580, he's 16, and he starts studying medicine at the University of Pisa.
And medicine was the mind.
The most lucrative career path available, absolutely. But you can see in the sources, he just found it dull. The rote learning, the established rules, total lack of experimentation. It was deeply unappealing.
Because his real fascination was already with the physical world.
Exactly. Motion, speed, how objects actually move and interact. He wanted better answers than the ones he was being given.
And we need to talk about what those accepted answers were, because that context, the intellectual world he was pushing against, that's what makes his actions so revolutionary.
Right. The entire academic world was still completely dominated by something called scholastic. This was a philosophical system driven by thinkers like Duns Scotus and Thomas Aquinas, and it had basically fused the physics of Aristotle with Christian theology.
A complete closed system.
A completely closed system. And scholasticism prioritized deduction, which is reasoning from general principles, and this unquestioning reverence for ancient authority, especially the ancient Greek polymath Aristotle.
So Aristotle said heavier things fall faster. And for hundreds of years, everyone just said, okay, Aristotle said it, so it must be true.
That's it exactly. It was a system based on philosophical agreement, not on, actually going out and checking. And Galileo, even as a student, was already challenging this. He started his own experiments with pendulums, with weights. He was naturally pivoting toward math and physics, a field that cared a lot less about established dogma. He never even finished his medical.
So he's emerging during this slow, kind of painful transition in European intellectual life. The world was finally starting to look backwards in order to move forwards.
That's a great way to put it. We often forget that, really sophisticated math and astronomy existed in Bronze Age Babylon. It hit these high points with Greek thinkers like Euclid and Archimedes. But after the Roman Empire fell, so much of that knowledge was just lost, or at least neglected in the West.
And it took centuries for it to come back.
Centuries. And we owe a huge debt to the Arab scholars in places like Baghdad and Cordoba and the Greek scholars in Constantinople. They preserved it, they translated it, they built on these core texts. The shift really starts in the 12th century, but the real acceleration that comes with Renaissance,
when they started physically digging up these old texts.
Literally digging them up and translating them. Works by people like Archimedes, who became a massive direct influence on Galileo.
And this whole intellectual reawakening, it wasn't just happening in a vacuum. It was being fueled by very practical needs, right? The age of exploration demanded better science.
Absolutely. The global voyages of the 15th century created this urgent, almost existential demand for better map, better measurements, better navigational. When you're trying to sail across an ocean, philosophical debates don't really help. Applied mathematics does.
It created a market for guys like Galileo.
A market for rigorous, results-oriented thinkers.
Exactly.
But the single most explosive catalyst of all was purely theoretical, and it was published just before Galileo was even born. Nicholas Copernicus's De Revolutionibus Orbium Coelestium in 1540.
Foundation. And incredibly dangerous. This text, on the revolutions of the heavenly spheres, argued for heliocentric.
The idea that the Earth and all the other planets revolved around the sun.
Which directly contradicted the accepted geocentric view, the idea that the Earth was the fixed, unmoving center of everything.
And the geocentric view wasn't just a scientific theory, it was fundamental Christian dogma. Yeah, the established view held that since humans were God's ultimate creation, the Earth had to be the physical center of the universe. To suggest otherwise was, implicitly, to diminish God's purpose for humanity. Galileo was part of this very first generation of natural philosophers, along with Tycho Brahe, Johannes Kepler, who were ready to actually study the world in this new, critical, and potentially heretical light.
Before he became the great astronomical challenger, though, he was a very practical, hands-on mathematician.
A very sought-after tutor. He studied math under Ostilio Ricci and spent time in Florence teaching something called disegno, or design. This wasn't art appreciation, it was applied mathematics. He was teaching painters and architects how to use geometry to get their...
Which brings us to that famous story from his time at Pisa between 1589 and 1592, the Leaning Tower experiment.
Ah, yes, the 56-meter high Leaning Tower of Pisa. It's just too good a setting to pass up. The story goes that he dropped different-sized cannonballs from the top to prove that objects fall at the same speed regardless of their weight.
Effectively demonstrating the principle of gravity long before Newton.
Well, demonstrating the principle, yes. But for you, our deep dive listener, we have to note that the sources are very, very skeptical about this. The main evidence comes from a biography written by a student of his years later. There's just no proof from the time.
So it's likely a great story, a myth that captures the spirit of what he was doing.
I think that's the best way to see it. It's a beautiful, instructive myth. It highlights the kind of thinking he was doing, which was directly opposed to Aristotle. He was publishing works like On Motion around this time, using logic to critique the ancients, whether he actually performed that famous demonstration or not.
So the principle of challenging theory with reality was the real point, not the theatrical draw. And that commitment to observation, it soon leads him away from Pisa and into what he would later call the happiest time of his life.
In 1592, he gets a much better offer, one that really addresses his constant money problem. The chair of mathematics at the University of Padua. It was in the Republic of Venice, which was powerful and, importantly, relatively liberal.
And he spent 18 years there.
18 years. And he later recalled it as the most fulfilling part of his entire career. This was a period where he could really thrive, both professionally and personally. He never married, which was a strategic choice, but he formed a long-term relationship with a woman named Marina Gamba. She came to live with him in Padua, and they had 3 surviving children, Virginia, Livia, and Vincenzo.
We have to pause on the non-marriage because that had huge consequences for his daughters later. Why did he keep the arrangement informal?
Well, there are a few reasons. First, Marina was considered below his social station, and a formal marriage would have complicated his career ambitions in the noble courts he was trying to get into.
Right.
Second, there was this lingering medieval tradition in Italian universities for faculty to stay unmarried, since many of them were also churchmen. And third, and most practically, I think, avoiding a formal marriage just helped him maintain a certain professional respectability, even though the children were born out of wedlock. They were illegitimate at birth, a status he'd have to fight to overturn for his son later in life.
It really paints a picture of a brilliant mind who is constantly calculating the strategic risks and rewards, both in his personal life and his career.
And during those Padua years, he was very focused on mechanics, building on the rediscovery of Archimedes. His first major book, La Bilancette, The Balance, was this highly technical treatise on hydrostatic balance.
How to figure out the density of things by weighing them in water.
Exactly. He followed that up with things like La Mécanique Mechanics and works on the military compass. These were practical books. They were about using math to solve real-world engineering and military problems. He wasn't just critiquing the past, he was showing how useful this new science could be.
But then in the early 1600s, his gaze, it starts to shift upwards.
It does. He observed supernovas, which was another contradiction to the Aristotelian idea that the heavens were perfect. He starts studying Copernicus, Brahe, and Kepler in real depth. He was gathering evidence.
And the big moment comes in 1609.
The true inflection point. He learns that a Dutchman invented a device for making distant objects appear near, and he immediately figures out how to make his own, much better version. The sources call it an instrument of very high magnitude, and when he pointed that device at the night sky, our understanding of the solar system was changed forever.
The observations came so fast, the winter of 1609, early 1610, and his findings were so urgent, so radical, he rushed them into print in this short little book, Sidereus Nuncius, the Starry Messenger.
Published in March of 1610.
Let's talk about those immediate breakthroughs, because they went right to the theological core of the debate. Let's start with the moon.
This is one of the most powerful and immediate shifts. The established view from Aristotle and the Church was that celestial bodies were made of this perfect, crystalline, ethereal substance, quintessence.
Smooth, unblemished, eternal. Nothing like our messy, corruptible Earth.
Exactly. And Galileo's telescope showed the complete opposite. He was the first to realize that the different shades on the lunar surface were mountains and valleys, like on Earth. He even used the geometry of the shadows to estimate the height of these mountains at about 4 miles high.
Which was incredibly accurate for his time.
Remarkable. The moon was imperfect, rocky, rough. It was made of terra, of Earth. That single observation conceptually unified the heavens and the Earth. They were made of stuff.
He also just blew up the tidy, contained little universe they had accepted for millennia.
Yes. He reported seeing vastly more stars than were visible to the naked eye, which challenged the whole idea of a finite, enclosed cosmos. It suggested a universe of potentially infinite scale. But the biggest revelation, the one that was a direct challenge to geocentrism, was Jupiter.
January 7th, 1610, the 3 little stars that turned into 4 orbiting moons, Ganymede, Callisto, Io, and Europa.
The existence of these moons proved, without any doubt, that celestial bodies could orbit something other than the Earth. The moon orbited Earth, sure, but here was a miniature solar system, Jupiter, and it's all moving together. This observation just demolished the argument that if the Earth moved, its moon would be left behind.
And the reaction to the Starry Messenger was just phenomenon. It created an international stir.
Unlike anything a scientific work had ever seen, there was this massive rush for astronomers everywhere to get or make better telescopes. But Galileo, being the savvy businessman he was, wasn't just interested in intellectual fame.
No, he used it as a marketing tool, a strategic move to get the lucrative patronage he'd always wanted. Yeah. Which is why we have the Medicean stars.
Precisely. This is a masterclass in early modern self. While the modern names for the moons came from another astronomer, Simon Marriott, Galileo immediately named them the Medicean stars after his patron, Cosimo II de' Medici, the Grand Duke of Tuscany, and Cosimo.
The book was dedicated to him. It was an overt, strategic piece of flattery.
Absolutely. He was aiming for a grand return to his native Tuscany and, more importantly, freedom from the constant financial insecurity and, as he put it, the pesky task of having...
And the flattery worked. almost instantly. Within months, he leaves Padua, gets the appointment of chief mathematician and philosopher to the Grand Duke in Florence. A huge professional win.
A huge win, but one that came at a staggering personal cost.
His family was splintered.
It was. The court position offered better pay, resource, freedom. But when he moved to Florence, he had to deal with the status of his illegitimate children. He brought his 2 daughters, Virginia and Livia, but because he needed to be respectable at court and didn't have dowries for them, he placed them in the San Mateo convent,
where they became nuns,
effectively cutting them off from the world.
It's jarring to think about, isn't it? The man who gave us the cosmos making such a pragmatic, economically driven decision about his own daughter's futures just to fund his research.
And his partner, Marina, and his young son, Vincenzo, stayed behind in Padua. They did. Marina died just 2 years later, still quite young. Vincenzo did eventually join his father. Galileo managed to get the Grand Duke to formally legitimize him.
But even then, there was friction.
A lot of friction. Galileo, determined to avoid the poverty he'd known, wanted Vincenzo to be a lawyer. But Vincenzo, like his grandfather, was drawn to music. He became a lutenist, which led to a lot of quarreling between them, though they did eventually reconcile. The tragedy of his daughter, Sister Maria Celeste Virginia dying young, also hung over his later years. Their letters show a really deep, warm relationship, despite the separation.
So with the security of the Medici court, Galileo is now welcomed into the highest intellectual circle. He's in the Accademia dei Lincei in Rome by 1611. But it was his writing, not his personal connection, that really sparked the flames of the Inquisition.
The first critical spark was a manuscript that got circulated. It's known as the Letter to Benedetto Castelli from 1630. Castelli was a former student, and Galileo was writing to him to rebut critics who were using the Bible to argue against his astronomical findings.
And the core message of this letter was politically explosive.
Incredibly. Galileo argued very strongly that biblical scripture should not be used as a rational basis for scientific argument. He wasn't saying the Bible was untrue. He was saying that faith and reason are separate, distinct ways of understanding reality.
That sounds reasonable to us now, but at the time, that was a massive, direct challenge to papal authority. The church saw itself as the final judge of all truth, including scientific truth.
Exactly. By insisting on the separation, he was trying to create a protected space for science, free from religious dogma, and in the process, he robustly defended the Copernican heliocentric theory, knowing full well how controversial that made him a target.
And the letter gets into the wrong hands.
A copy was obtained in late 1614 by a Dominican named Niccolo Larini, who immediately sent it to the Roman. The investigation officially launched in early 16.
What's amazing is how this investigation into Galileo suddenly made the church realize they had overlooked Copernicus for decades.
It's incredible, as Copernicus's book had been in print for over 70 years. It was so mathematically complex that not many people read it, and the church had never formally condemned it. Now suddenly they rushed to correct this oversight, and Copernicus's work was finally placed on the index of prohibitives.
And Galileo himself was called to appear before Cardinal Robert Bellarmine, one of the sharpest minds in the Inquisition.
Yeah, that 1616 meeting with Bellarmine led to the official record is a bit disputed, but the consensus is that Galileo escaped with a slap on the wrist. He was explicitly warned not to hold or defend the Copernican doctrine, and that word defend is key.
So he went quiet on heliocentrism, at least openly, for over a decade.
He did. He pivoted to safer topics, he focused on scientific methodology, but he was still pushing boundaries. His work on the tides, for example, a discourse on the tides, his core argument was scientifically flawed, but the attempt itself.
What was he arguing?
He was trying to prove the Earth moved without explicitly saying the sun was the center. He argued that the tides were caused by the Earth's dual motion, its daily rotation, and its annual orbit, causing the water in the oceans to slosh back and forth.
A purely mechanical explanation.
Purely mechanical. The problem, as Newton later proved, is that it completely ignores the gravitational pull of the moon, the main driver of tide. But even though he was wrong, it was a vital contribution because it started the conversation about how terrestrial events, like tides, were connected to the Earth's place in the solar system.
This all leads up to what I think is one of his most important, though maybe less dramatic, books, Il Saggiatore, the Essayer, from 1623. This is where he basically defines the scientific method.
It's truly foundational, and it came out of a big debate with a Jesuit scholar, Father Orazio Grassi, over a comet. Grassi argued the comet was a supernatural object sent by God. He was using traditional Aristotelian logic.
And Galileo's response wasn't just about comets.
No, he elevated the debate to epistemology, the theory of knowledge itself. He asked the fundamental question, how can anyone be sure their reasoning is sound when they're assessing scientific truth?
And his answer was that the book of nature is written in the language of mathematics.
That's the revolutionary line. For the scholastics, the book of nature was written in theological terms: purpose, essence, authority. Galileo said no. Nature is written in triangles, circles, geometric figures. It's written in numbers. If you want to understand something, you don't debate its essence, you measure.
Stop quoting old books and start measuring.
That's the core of it. This is why the book is called the Asset. He who judges the composition. He was providing the tools to properly judge reality through calculation, and this directly influenced the next generation, including René Descartes.
And even with the threat of the Inquisition hanging over him after 1616, he managed to maintain his influence through this scholarly network, the Republic of Letters. It was a brilliant way to get around censorship.
A crucial lifeline. The church policed printing presses very carefully, but the circulation of manuscript letters between scholars all over Europe allowed Galileo's ideas and his research to spread, completely bypassing the censors.
And it had a real-world impact.
Oh, a huge impact. His correspondence with Nicolas Claude Fabry de Peiresc in France, for example, inspired de Peiresc to apply Galileo's methods to geography. By observing lunar eclipses from different locations, de Peiresc was able to accurately calculate longitude and prove that the Mediterranean Sea was about 1,000 kilometers narrower than everyone had thought.
So Galileo's influence was flowing outward, shaping science across Europe, even when he couldn't publish. But that publishing silence couldn't last forever.
No, it couldn't.
In 1632, he shatters it, dramatically, fatally, perhaps. With the dialogue concerning the two chief world systems, he's almost 70 years old. Why now? Why break that promise from 1616?
Two things: legacy and misplaced confidence. He felt he was running out of time and needed to get his definitive argument for heliocentrism into print. And he was overly confident. He thought he was protected by his powerful patron, the Grand Duke. He also misjudged the new Pope, Urban VIII, who he thought would be open to a scholarly debate.
Terrible miscalculation. And the structure of the book, framed as a dialogue, was the strategic choice that led to his downfall.
It was. You had three characters: Salviati, who is the brilliant, persuasive advocate for the Copernican sun-centered view. Then you had Segredo, the intelligent layman, the neutral observer who is ultimately won over by logic. And then you had Simplicio.
Simplicio, who argues for the traditional Earth-centered view, the official position of the Catholic Church.
And that was the fatal flaw. The dialogue was obviously rigged. Salviati always wins the argument. But giving the defender of the established papal-endorsed position the name Simplicio, which clearly suggested simple-minded or fool, was seen as a profound public insult.
And Pope Urban VIII took it personally.
Very personal. He believed Galileo had deliberately used the character of Simplicio to mock and the idea of papal infallibility.
And you have to remember the political context here. This wasn't just an academic spat. The church was under immense stress from the 30 Years' War raging across Europe.
Absolutely. Europe was tearing itself apart. The papacy could not afford to look weak or divided on fundamental doctrine, especially not in its own backyard. When Galileo challenged dogma, the church saw it as giving ammunition to their Protestant enemies.
But beyond the controversy, the dialogue was scientifically critical because it summarized his work from his long silence. We have to talk about the science here, starting with the phases of Venus.
The phases of Venus were crucial. You can only see them with a telescope. And Galileo observed that Venus shows a full set of phases, just like our moon, from a thin crescent to a full disk. This was impossible in the old Earth-centered model. The only way it could happen was if Venus orbited the sun. It was direct observational proof.
And then the concept of Galilean invariant, or relativity, which becomes foundational for all of modern physics.
This is maybe his most lasting contribution outside of astronomy. Galilean invariance is the core idea that the laws of motion are the same for everyone, as long as you're moving at a constant.
The famous ship experiment demonstrates.
Exactly. Imagine you're inside a large ship, moving smoothly across the water. You drop a rock from the mast. If the ship is moving steadily, the rock will land at the foot of the mast, not behind it. The movement of the rock is relative to the steady move, so you can't tell just by observing things inside the ship whether you're moving or...
So the Earth itself is just a giant ship in space. We don't feel it moving because everything on it, the air, us, the rock, is all moving at the same steady speed.
Precise. This brilliant concept solved one of the biggest objections. If the Earth is spinning, why aren't we all throwing Galileo's relativity? Why? And this concept directly informed Newton and, centuries later, Einstein.
But despite the power of that science, the Inquisition only cared about one thing: heresy. The 1633 trial was quick and brutal.
It was terrifying. He was officially put on trial, threatened with torture. The charge was suspicion of heresy because arguing the sun was the center of the universe contradicted the idea of Earth as the literal unique focus of God's creation.
He was a man of science, but he was also 69 years old and facing a very real threat of imprisonment or worse. The recantation came.
He was a pragmatist, facing the horrific prospect of unpleasant imprisonment. And let's remember, Giordano Bruno was burned at the stake for heresy just 33 years earlier. Galileo immediately recanted. He publicly swore that he abjured, cursed, and detested the error of the Earth's movement.
And for historical accuracy, we need to debunk the myth that comes with this moment.
Absolutely. The famous quote, "Eppur si muove and yet it moves," supposedly muttered under his breath after he recanted. It's a beautiful piece of historical. It was invented decades later to give him a romantic defiance. Didn't happen in that court. Galileo was a broken man, but a survivor.
His sentence was commuted to house imprisonment in Tuscany, first in Siena, then at his country estate at Arcetri near Florence. What were the conditions like?
They were restrictive, but not total isolation. His movements were limited. He was under observation by the Inquisition. He was required to read the 7 penitential psalms every week, which, wasn't a huge punishment for him, as he remained a faithful Christian.
The biggest challenge wasn't the confinement, it was his health.
It was. He suffered from a severe hernia, arthritis, and then, heartbreakingly, he went completely blind. Ironically, his failing health actually led to his house arrest conditions being loosened a bit so he could travel to Florence for medical.
And the terms of his arrest banned him from publishing anything that conflicted with church teaching. But he completely defied that order, didn't he?
He did. He was obsessed with his legacy, determined that his life's work would not be silent. While confined at Arcetri and before he went blind, he managed to complete his discourses and mathematical demonstrations relating to 2 new sciences.
And what were these 2 new sciences?
This was a summation of his earliest interests. The first was the strength of materials and engineering, how large structures withstand stress and break. The second was the study of accelerated motion and projectile paths. He was finally formalizing his work on gravity and acceleration, providing the mathematical proof. It was his technical math.
And given the ban, how did he get it published?
It was a cloak and dagger operation. He corresponded secretly with friends, and the manuscript was smuggled north to the Dutch Republic, to Leiden, one of the most liberal places in Europe, where it was published in 1630.
And the church didn't retaliate?
No. By that point, he was elderly, blind, and ailing. They chose not to act, perhaps calculating that further persecution would only make him a bigger martyr. He was allowed to live out his final years quietly, nursed by his son Vincenzo, with whom he'd fully reconciled. He died on January 8, 1642, at the age of 77.
And even his burial was a battleground.
A very bitter one. The Grand Duke wanted him buried in the main chamber of the Basilica of Santa Croce in Florence, next to Michelangelo. But Pope Urban VIII, still bitter, blocked. Galileo was buried in a remote corridor. It took almost a century, until 1737, for his remains to be moved to a proper monument in the main basilica.
But despite all the attempts at censorship, his legacy just exploded, especially in Northern Europe.
His early works in Latin were easily republished in places like Antwerp and Amsterdam, where the index of prohibited books didn't matter. And his later works in Italian were quickly translated. This ensured that the groundwork for the scientific revolution was set, ready for the next generation.
And the greatest of that next generation was Isaac.
Without question. Isaac Newton, who was born the same year Galileo died, his great work, the Principia Mathematica, could not have existed without Galileo's mathematical approach to motion and his concept of invariance. Newton built directly on Galileo's foundation.
And later figures like Einstein and Stephen Hawking saw him
as the father of modern science. Not just a predecessor, but the father, because of his absolute insistence on measurement, experimentation, and mathematical description.
Brings us to the ultimate question. Did the institution that prosecuted him ever fully reconcile with his legacy? The Catholic Church took centuries.
It was a glacial process. The first crack was in the early 18th century, when the ban on reprinting his works was quietly lifted in Italy. Then in 1741, Pope Benedict IV authorized an edition of Galileo.
A tacit admission that the church had been wrong.
A tacit admission. No formal apology, but a clear The index of prohibited books was finally dissolved in the 20th century, and Pope John Paul II came very close to offering a full formal apology, admitting the Inquisition's action.
But the scars of the Galileo affair still linger, don't they? The controversy around Pope Benedict VI shows that.
They absolutely do. In 1990, when he was still a cardinal, he stated that the Inquisition's actions against Galileo were reasonable and fair. That statement resurfaced in 2008 and shows the enduring defensiveness around this chapter. It highlights that even centuries later, the relationship between faith and evidence is still a topic of intense discussion.
So we've traced this extraordinary and costly journey from a financially struggling mathematician who used patronage and clever marketing to get the resources he needed to the intellectual revolutionary who dared to turn his telescope on the heaven. He used observation to confirm a cosmic view that challenged 1,500 years of dogma. His work created the foundation for modern physics, but it cost him his freedom.
It cost him everything.
And so, here's a final thought for you to consider. Faced with the immediate, terrifying threat of torture, Galileo instantly recanted his beliefs. Was that act of recanting a profound personal betrayal of the scientific truths he'd spent his life proving? Or was it a cold, practical, strategic move away to survive, to finish his most important work, the two new sciences, and ensure his revolutionary ideas lived on unmartyred to influence Newton and Einstein?
A question of courage versus pragmatism.
Thank you for joining us for this deep dive into the extraordinary and expensive life of Galileo Galilei.